Welcome to the State of Developer Education, a podcast by Major League Hacking. We explore how technical leaders are creatively tackling the developer education gap to help prepare the next generation of technologists for the real world and build businesses that can adapt to any changes in the technology ecosystem. I'm your host, John Gottfried. Hey everyone, welcome back to the State of Developer Education. I'm so excited for this week's episode with Arielle Mella, who is a developer advocate at Viam. How's it going today?
I'm doing really well. It's a beautiful day in New York City. It's very sunny, good weather. It's Friday, so I'm happy.
Love it. I'm also in New York, and I feel like the seasonal change. I appreciate having like the early morning sunlight. So, Arielle, I know that you've been involved with developer education for a long time, focusing on everything from general coding education to robotics now. I'd love to start with your origin story. How did you get your start and sort of end up where you are?
I love this question. I had a pretty unconventional path into robotics now. I guess we can go all the way back to high school. I went to like a very academic, very demanding high school. And I remember one summer, everyone had like internships lined up. And I didn't even know that internships
In high school.
Yes, in high school. And everyone was doing like summer internships, research positions. And I had no idea. So I started looking around and I was just like, oh man, like what can I do this summer? I didn't know that I had to be gainfully employed as a 15-year-old. And as I was poking around online, I was very interested in art. And I found this art and technology gallery in New York City called iBeam. And they were running a summer program that was called Playable Fashion. And it was kind of a bit of fashion and programming and game design. And their deadline was open. And I was just like, you know what, maybe I should apply to this and see what's up. And I didn't have any background in programming, anything tech related. But I knew I loved art and I knew I loved creativity. So I said, why not? When I went there, I was immediately surrounded by like a bunch of really talented artists and creative technologists, which was a field that I didn't even I didn't know that existed. And immediately we started by I forget what it was called, like the scrapyard challenge, where basically like we broke old toys and we just like looked at their circuits, and then we were just workshopping like, how do we rebuild this and what can we make out of this? And then that transformed into let's start making games, board games, analog games. Okay, now let's start game design. Let's look at Unity. Let's start learning code loops. And it all happened really quickly. But it just really opened my eyes to a world of possibilities where I was like, wow, technology is actually very much a huge part of entertainment. And after that, I was just like, it was like a switch clicked in my head. And I was like, I want to do this for the rest of my life. And I want to follow in the footsteps of these mentors. And I want to abandon all my plans of being a doctor. And I want to just like do creative technology and art. So I, spoke to those mentors at those programs and looked at like what schools they studied in. And I found myself going to Parsons, studying design and technology, which is like a crazy major because it's like, what is that, right? And, the famous joke, like, oh, my work lies in the intersection of art and technology. But that's truly what it is. And you learn a bit of fine arts and you learn how to paint and you learn all the design basics, and then you start experimenting with code and technology, and how do you blend those together, and how do you look at technology and code as a means of expression and art. So that was just like very inspiring to me. And you're surrounded by all of these really talented people with just like crazy ideas. Nobody's working on the same thing. It's like, it's so inspiring to be surrounded by that. So moving forward, I was like, because of the programs that I was fortunate enough to participate in as a teenager, how can I like pass this forward as I'm studying? And I started looking at community spaces and maker spaces and tech education spaces, and started working as an instructor where I would kind of teach anything from coding to little children, or how to fabricate 3D print, 3D model with teenagers, just like very well rounded, a little bit of everything. Um, and then I started getting really interested in building physical computing projects. And that translated to making interactive art gallery installations, having my work featured at Baby Castle, just like small community spaces in New York City. And it's like everybody knows each other in these spaces as well. And just putting my work out there and like helping. I always was really excited to kind of like help the future generations and work with those students to make those ideas, because I was right there just a few years ago too. And then I found myself like working a lot with open source projects and, being really inspired by those communities online. And I found my current company when we were very young, Viam. I think I was probably like employee number 30. So we had a very new product. It was like a framework. We didn't have any documentation. We didn't have any content. And I was one of the first developer advocates hired there. And it was kind of our job to, again, do what I've been doing for years, get creative with it, start making things so that you can inspire other people to also make things. And here we are.
There is so much cool stuff to unpack there. I have heard of iBeam before. I know a couple of other people that have been like tangentially involved in it, and it's always been one of those programs that I'm like a little envious of, because it is at that intersection of like art and technology. I also heard you mention Baby Castle, which I've been to a couple of exhibitions at. Would you care to explain it for anyone who's listening who's like, what is that?
Oh, absolutely. Baby Castles is a community space where it was mostly for game designers and kind of like creative technologists to feature fun work. When I would go, it was like this little basement apartment around 14th Street, and people have like these homemade arcade games and these really interesting projects that people could go and play test. And it wasn't just like an arcade. It was a community space where people would share feedback, share ideas, workshop things. They had classes, and it was just a really great space.
Thinking about art and technology, so like I know you got your start there. I kind of share that philosophy that technology has many elements of art. um I'm curious to hear your thoughts on like typical computer science education and how it sort of relates to that, because it does feel like there might be these like tensions of pull in different directions between the creative applications of technology and perhaps the uh, money making applications of technology. Well, what's your perspective on that?
Typical engineering classes and typical programming classes never spoke to me, because in my brain, I felt like I couldn't contextualize a lot of the things that I was trying to learn. I'm a very visual person. I'm a very hands-on person. And I learned almost a little late in life that the best way for me to learn and be successful with like a new topic is I have to actually get my hands in it and make something that is responsive, or make something pretty so that I can actually understand what I'm making. So I guess just speaking from my experience, I think that the divergence of the two kind of tries to separate them. And so I guess people are almost like scared to approach programming as a creative discipline, because it's not the traditional, like, we're going to make apps and we're going to make websites. But if you think about all of those things, they are inherently very creative anyway. And problem solving is a very creative thing as well. So I find it very interesting that people try to almost separate the two when I don't think they should be separated at all.
I actually find that hackathons, which I know you've been heavily involved with, we could talk about that a little bit, but hackathons are kind of a place for a lot of students where those two things finally do intersect. Like you might go to a computer science class and learn all of these really academic topics, and you might go to a hackathon and it's like off the wall weird ideas. And
Mhm.
you may have been thinking about tech as a career pursuit, but having environments that are a little bit more abstract and open ended can expose people to like I don't know, like the fun and sort of like artsy side of it as well. I know, coming full circle here that like you've been a mentor at a lot of hackathons, like especially for Viam. What is that experience like? Like, does that feel similar to your start at iBeam? Like, does it differ pretty significantly?
Oh, absolutely. My favorite thing about hackathons is you don't just jump in and start writing code. Everything starts with ideation. And it brings me back to, my days in art school. You're like not allowed to start a project unless you start with those concept sketches and you come in with the plan and you get creative and you prototype and you think of 8 different things before you settle on that first thing, or that final thing. And with hackathons, it's encouraged that dialogue is encouraged. Meet new people, and don't be afraid to try that new tool and go up to that booth and learn about that new thing so that you can make something really, just like outside of your skill set, because that's what you're there to do. You're there to learn, you're there to push the boundaries of your knowledge and what you're capable of. And you want to just, be really successful, whether that's like winning prizes or making a really awesome project for your portfolio. So when I'm involved in those things, I love to just like sit down with folks and say, okay, they come to me and they're like, well, I want to use this framework. I'm really good with this language, and this is my idea. And I'm like, those are great, but let's take a step back, right? And let's break it down and let's think about the problem we're trying to solve, whether the hackathon has some creative prompt or some overarching theme. And let's like make a mind map, right? And start coming up with different topics here and there. And then you'd be surprised that like so many other things come out of that. And I think that in like hackathons, you have that space to kind of go wild with those ideas. But perhaps if you're like, in a traditional like engineering role or job, like you don't have that space to kind of think outside the box, which is why I really love these programs and, workshops, hackathons.
How do you feel like the competitive aspect of hackathons like changes things? Because I don't usually think of art as competitive. Maybe it is. I'm not like in that world, but do you think that changes the dynamics at all? Is it a good thing? Is it a bad thing? Like, how does it influence it?
I actually have been to like a couple hackathons where I could see almost like the vibes change because big sponsors are offering like bigger prizes, which are obviously great, but I feel like it almost closes people off to ideas because then they come in and they're like, I'm going for that grand prize and we're going to use this database and we're going to use this tool. And I feel like that almost like limits the ideation, and that like the first 4 hours, the first 6 hours of the hackathon are so crucial because it's a big chunk of your time, but it's also that's when you decide what you're going to do. So I really like when hackathons are a bit more open-ended and the prize categories are decided later. So does that answer your question, Will?
I kind of agree with what you're saying. Like, when the incentives are too big, it can sort of warp how people approach the event. If it's
Yeah.
like little spot prizes, it usually doesn't have that big of an impact. But if
Yeah.
you're offering like $10,000, that definitely changes how someone spends their time.
Yeah, absolutely. But then like you think of other hackathons where the prizes are more physical objects, or maybe like an internship or an opportunity to talk to someone. I noticed that there's a lot more creativity that happens,
Mhm.
and people are excited to actually pick up that new tool and try that new thing. And oh, let me do something that I've never done before because it's okay if I don't, right?
Yeah. for a big part of your career, you were, involved in teaching in what I'll call like a direct fashion, right? Like you were literally teaching people to code through a variety of different programs. What are some of the things that you have seen evolve about how people have learned to code over the like span of time that you've been doing it? Because things change so quickly in tech.
Yeah, absolutely. So when I first learned to code, I learned to code with a pen and paper, which is so ridiculous, in my opinion. I took AP Comp Sci in high school, so it's incredibly standardized. You use Java, and you're, testing your programs on your laptop, but you need to actually memorize how to write these loops, and you have to memorize where the semicolons go and everything. And if not, you're docked like actual points on an exam that could impact like your college or whatever. And that was like a terrible entry for me, the design brain person, into computer science. And it almost turned me off from it because I felt like I am not going to be able to master all of these things. It's if I don't memorize exactly how to do this algorithm, I'll never be successful. Um, and then as I started teaching, I almost made it my own mandate to make sure that I made space for alternative learners. And how can I teach these same concepts, these fundamental concepts that tie into all of these other things that I struggled with, but in a more creative way. And now all of these really great tools exist. I mean, one of the most common ones that kids love to start with, Scratch, MIT, and that's just like a drag and drop coding program where you can, make little sprites animate and you can create some game logic. But if you think about it, you're learning all of the code fundamentals. You're learning for loops and you're learning all. And it's really great that these tools exist. And then, now later in my career, when I was teaching, there are actual toys and products that, kids can actually program and make, like create robot controls and responsive things, but it's almost gamified and it's fun and it's creative, but you're still learning all of those things. And then moving to more advanced topics, when you're actually, learning a language, there are all of these like tools and frameworks online where you can just kind of, it doesn't matter if you don't memorize the exact syntax because there are like open source communities, there are people who can help you, there are forums online, and just like finding all of these things and seeing how that's changed over time. I'm just like, it's not that hard to get into. There are people out there that are willing to help you. There are people who make tons of content, YouTube videos, tutorials. YouTube got me through college. And but if you think about it, it's like that's what I'm doing today too. It's the same thing. So it's been really remarkable to see that change over time. And I'm almost a little jealous of the newer generations because, now it's part of their core curriculum where they start learning technology in the first grade. And I just think that's so beautiful because
Yeah.
if we have come this far and a lot of us learn tech so late in life, imagine what the future is going to look like when, we spark this curiosity so young.
Did you have a project in AP Computer Science that revolved around fish?
Around fish?
Yeah.
Um,
I don't know how quickly the curriculum changes, but I have this like
I don't really
core
remember.
memory of building a Java app that was meant to represent some kind of like underwater ecosystem with fish. And the way that they explained object inheritance was you had a fish class, and each species of fish inherited from that fish class
I
and
think
like
I
context,
remember this.
right? This is
Yeah.
like a core memory I have from like high school.
Oh wow.
I know
Did
I'm going like
did you
way.
also did you also use like Blue Jay or something to
I don't even know.
I don't know, we used
All I
some.
remember is the fish.
Yeah, I remember nearly failing that class. So I did not do well in that class because I just like it was hard for me to wrap my head around these concepts. Putting outputting numbers and
Mhm.
outputting like it didn't make sense to me.
Yeah.
In college, one of my favorite classes that I took, it was called creative coding,
Mhm.
which is very non-specific, but we learned JavaScript, we learned P5.js, which is an open source library designed for artists and designed for creatives to make interactive art or algorithms and generative art. And once I started learning programming with that, everything clicked. I was like, oh, duh, this is how these things are inherited. And this is how I build these classes because I can actually see that output. Maybe I
Yep.
should revisit the fish project, but in a
I
visual.
don't know if it's a good project or not, but I
Maybe it's
definitely
not.
remember it.
Yeah.
Uh, it's interesting that you're like talking about how it's almost like the numbers on a command line didn't resonate. And I hear
Mhm.
that from so many people where the way that coding is often taught, uh, it's like you learn all of the concepts, but when people think about technology, they're not thinking about the concepts. They're thinking about like, what do I want to do? What do I want to accomplish here? And that's so many layers disconnected from like how a print line works or how a for loop works
Mhm.
that people just like don't understand how like what it takes to get from A to B. And and I think we like tech loses a lot of people as a result. But with hardware, it feels like that gap is much smaller because you're learning how a for loop works and your LED is blinking as a result of looping. And that's really cool and easy to understand. Like, ah, yes, like I got from point A to point B and I get a satisfying result from that. That's not
Absolutely.
just like text.
Yeah.
Yeah.
I completely agree. I think, that was also one of my gateways, is like making simple robots because now you're taking those responses and those outputs and putting them in the physical world, in the physical space, and it just makes so much more sense.
So how does Viam play into that? Like, I know that you all are kind of approaching robotics in a fairly like novel way from how I understand it.
Mhm.
Can you tell everyone more about that? And I'd love to like dig into that a little more.
Yeah, absolutely. So Viam is a cloud-based platform for managing robots, whether that's configuring, controlling, or deploying code, whether you're a hobbyist or a business or trying to scale, a whole industry. We've got something for everyone. And the cool thing about this platform is that the barrier of entry into robotics is, or hardware specifically from a software standpoint, is very challenging, right? And the inverse is also true. If you're a hardware engineer, how do I kind of connect that and start writing high level code? And, so our platform is trying to bridge the gap for all of those developers and streamline that process so that when you're prototyping and when you're building your robots, you can spend less time on configuration and actually getting the things to communicate and work together, and spend more time actually fine tuning and designing what you want, whether that's making a more complex robot or actually designing the physical thing, spending more time on the mechanical engineering, to bring your ideas from prototype to actually production in a much shorter time.
Interesting. So I saw an example of this that you built. That was I think it was a robotic like Halloween candy bowl,
Yeah.
which is really cool concept. Can you just like explain a little bit about like how that system works with VM? Because like when I think about robotics, and probably a lot of people, it's like, great, I have an Arduino, I have a bunch of wires, maybe I click a button to deploy code to it, and that's kind of the extent of how all of that works. You know, what changes when you're using this more advanced platform?
Yeah, great question. So one of the neat things about VM is that we are hardware agnostic and we like to kind of abstract a lot of the hardware within our robot development kit or RDK. It's an open source part of our product that exists online. So in simplest terms, a motor is a motor, a camera is a camera. You don't have to worry about all of those different drivers and compatibility. We kind of like do all of that for you. So with the Candy Bowl project, I thought it was a fun challenge. And, I've always been a tinkerer, even as a young age, I would always take things apart and put them back together. So I wanted to challenge myself. Could I buy anything off the shelf? literally anything off the shelf and get it running on our platform and make it smarter. So I love Halloween. It's one of my favorite holidays. Let me buy this $15 bowl off of Amazon, and break it open and see what I can do. So at its simplest parts, you crack it open and it's just like a photoresistor, which detects motion, and a motor on a rack and pinion that just like pushes the hand in and out. Very simple, right? How do I make this actually smart? So, like you mentioned earlier, you grab a board, right? So I used a Raspberry Pi. And because our hardware is agnostic in our platform, I didn't have to look at any like spec sheets or anything. I just look at like a Raspberry Pi pinout guide, and I'm like, okay, let me connect these GPIO pins. Okay, now can I write a simple method to make this move back and forth? Done in 5 minutes. Okay, now let me level this up. How do I maybe detect motion? Well, let's use something smarter. I grab like a cheap webcam, probably like $20, screw it in the eye. Great. Plug that in. In like 2 minutes, it's connected to the Viam software. I can start writing code against that very quickly. How can I make this smarter? Well, let me leverage machine learning and vision service. And, so in just a few hours, I took something incredibly simple and I was able to implement some of the like hardest topics in robotics in less than an hour. And I think that's amazing.
Yeah, that's kind of incredible. I'm sure anyone listening who's done hardware work understands how painful that normally is. Like as
Yes.
you're describing that, I'm like thinking, oh yeah, like I tried to use a webcam once with a Arduino, and finding the right like drivers and libraries and making it actually like talk to my other components was kind of a nightmare.
Mhm.
And it's one of those things where I imagine that, when you start using it, there's like a magic to it that
Yes.
simplifies things so drastically, where it's almost like, if you haven't done hardware before, it's like, wow, this is magical. It just works. If you have done hardware, it's probably like, wow, this
Where has
saves
this
me a
thing
hundred
been?
hours of like reading spec sheets.
Yeah, exactly. And also, when I'm before using a platform like this, your typical, way to prototype is like you connect everything and then you have to actually write code just to see if the thing moves a couple centimeters, right? Well, we have flexible SDKs in a bunch of languages where we have all of those methods for you built in to all these different components too. So you can just look at our docs and say, oh, move four, very simple. You don't have to do any calculations or anything. Yeah, I think it's really great.
That's really cool. What are you seeing your community do with these large language models merged with robotics?
So we have this new thing in our product called the modular registry, where people can actually create modules that either wrap existing drivers, libraries, so that they can integrate seamlessly within our platform. So you're not completely stuck with just the things that we've built into our system. You can write your own. It's very flexible. So with all of these new open source technologies and AI technologies, people in our community are even building these integrations so that they can, use Hugging Face AI detection in and leverage it against the VM platform. So then you can take, these two super tools and then even streamline your idea even faster. We have a project that one of our developer advocates made that we're leveraging chat GPT and creating robots that talk to you. And think like 5 years ago, that would have taken a whole team of people to accomplish. And you could probably bang out a project like that in a day or so now because of all of these amazing open source tools and AI tools that are free to use, open to the public.
Yeah, that's super freaking cool. I mean, there's definitely something there. It feels like we're at the stage where people are like tinkering and seeing what the coolest thing they can accomplish is, but it's so different than how people perceived AI a couple of years ago, which was almost like the realm of PhDs, right? And now it's
Yeah.
accessible to normal developers. Speaking of like normal developers, What are some of the main differences that you've seen between teaching people to code, right, which I would imagine is largely children based on what I saw in your background,
Mhm.
versus teaching people a platform as a developer advocate?
Oh, that's a great question. I think that the simplest level, I actually wouldn't say there is a huge difference because the primary motivation between developers and children is that they want to make cool stuff. And developers are always very excited to get their hands on that new thing and make something. And kids, in my experience, are the exact same way. So when I'm approaching teaching a new topic, whether that's in my classroom or as a developer advocate, if your audience has that excitement to build and create things, I actually don't really see a huge difference.
When I was reading your piece about the robotic like Halloween the bowl, that's what we call it, Halloween bowl, it reminded me of some like blog posts and tutorials that I had written when I was at Twilio, where obviously it wasn't a commercial use case, but it was something that developers would get excited about and have fun with.
Mm,
And I don't know like where VM at is in terms of like developer advocacy, but like there is kind of an industry wide trend towards more commercial focus and more ROI focus. But to me, that kind of loses some of the like soul of working with developers and making stuff that is exciting and fun. I don't
yeah.
know. I mean, if you have any thoughts on that, but
Yeah, I
yeah.
do. So a lot of the tutorials and content that my team produces, they are very playful and fun and developer focused, get that excitement going. But I've been in customer meetings where people actually point to these tutorials and say, well, yeah, Arielle wrote this tutorial on machine learning to make a pet feeder for her dog. But if you think deeper about it, like there you can apply this to so many different things. So part of the magic of working at a startup is that you still have this flexibility to create all of those really fun novel projects that could speak to industries and that ROI, capital drive. A good example of this too is we went to ICRA, the International Conference for Robotics and Automation, last summer, or yeah, this past summer in London. And my team was tasked with making a cool robot that draws people to our booth. And ICRA is like a very academic conference. So how do we show off our platform and say, hey, we have all of these great capabilities that could apply to your research, and there are all these businesses and startups there. Hey, we could be a great tool for you. But also we've got the small developer advocacy team that loves to make fun projects. What is that intersection, right? And I love games, so we created an arcade game. We created a replica of the robotic the claw game. You ever go to an arcade and you try to pick up a stuffed animal and you think, man, these things are rigged because no one can
Yep.
ever win these? So we tried to challenge ourselves. Can we build this in an hour? So we went to our lab and we we had like a robot arm and we had some water bottles and stress balls around the office. Could we program a claw game in under an hour? When we ended up building out this kind of final fantasy, and we had this beautiful UI that we made with our TypeScript SDK, and we were controlling a robot arm with motion planning, and we brought it to this conference. It was almost like a gamble, like, will people like this and will people take this seriously? But then, the industries and the companies that were looking at it, they were like, this is very impressive because you're using motion planning and you're using vision detection. And in my business and in my warehouse, we can absolutely use these tools and we could build, we made a little gamified, cute interface on an iPad, but that translates to we can build dashboards for our robots easily on your platform. So I'm advocating always on my team that we shouldn't be afraid to make these fun, cool projects because if your underlying tool is very powerful, I think people will see it regardless. If you're making that candy bowl project or you're making that how to build this for your GPU business tutorial.
Yeah, people can make the logical jump of how it applies to their own use case without having it spelled out for them, basically.
Exactly. And
Yeah.
that's what we love to do.
I mean, I absolutely love that as an approach. And I do think that having those kinds of like qualitative, case studies of like, hey, people do understand how this translates into a commercial use case is so incredibly powerful. And um, I think a lot of people underestimate the how powerful that is from an actual like business standpoint.
Absolutely. And I guess that ties into one of your first questions that you asked on this podcast, like why do we separate creativity
Yep.
from the computer science that can make us money? They're the same thing.
Yep.
If anything, the creativity could be more powerful and
Mhm.
drive more conversations and more interest and more people to your thing that you want to build.
If you were in control of how people learn to code, how would you bring creativity back to that? Like
Oh,
imagine the typical CS classroom, that APCS course, perhaps.
yeah. I would say for the first few weeks, we're not even going to touch a computer. We're going to start thinking about programming in an abstract way. And we're going to think of ourselves as computers and robots. And we're going to learn how to program each other. And let's build, paper prototypes and low level prototypes of the things we want to build so that we can understand how these infrastructures of code talk to each other. And let's think about what's something fun and creative that we could make that responds to us or is like a responsive design project, right? And let's make that our first project and see how that sparks the interest of different people in the classroom because not everyone learns the same. There are alternative learners, people are visual learners, etc. And then you can move back into the textbook and move back into the all right, let's do those number outputs, but then it creates a different context for that learning in their minds. And that's how I would approach it in my classrooms. And I'd hope that, more people do that as the industry shifts.
Yeah, absolutely. Oh, have you ever worked at a summer camp?
Yes, I love summer camps.
I was gonna say, like, hearing you describe having people pretend to be computers and execute instructions just like gave me flashbacks to being a camp counselor because those are the kind of like activities that were like slightly educational, but almost like secretly educational that you
Yeah.
sometimes have kids do.
Yeah, I do love that. I think the best way to get people engaged is through play. Like I've always felt that way. I'm sure you can look at my projects as a developer advocate at Viam. They're all very playful. Just like get people excited about occupying space and taking up space with your technology. And then that's a great entryway building those big ideas.
But one of our board members wrote this essay, and there's this pull quote from it that I always come back to, which is that they believe that education at every level should combine the joy and playfulness of preschool, the intense collaborative experimentation of a hackathon, and the deep self-guided exploration of a doctoral program. Which is like such a powerful quote to me because I'm like, oh yes, like that is what I wish school was like.
Yeah,
Yeah.
definitely. I think I was very fortunate to have that art school education because
Mhm.
we were able to kind of hit all of those three metrics that you just mentioned, where we had that playfulness, but then we did that deep exploration, that deep technical, dive into
Mhm.
the things we were making. And we learned to think about it in that way.
Yeah. Maybe more programmers should go to art school.
Honestly.
Beyond VM and your own work, are there any like educators, creators, people out there like teaching this stuff in a novel way that you really look up to and follow?
Yeah, absolutely. So one of my favorite digital artists, I don't know if you've ever heard of him, Zach Lieberman.
Oh, I'm
Um,
not familiar.
so have you ever heard of open frameworks? So
Yes.
he actually, yeah, so he is the creator of Open Frameworks. It is an open source C++ framework for creative coding, beautiful graphics. And through his open source creation, he also has this education program called the School for Poetic Computation.
I do
Yeah,
know people who are involved with that. That used to be at Orbital, right?
yes,
Okay.
I think so. So I just like creatives who approach technology with this kind of mindset is just so inspiring to me. He's also an alum from my university as well. So I guess you can kind of you can connect the dots there too, kind of like approaching technology with that creative spin. One of his earliest projects is a robotics and machine learning project, actually. And it's like solving a real world problem in a fun and creative way. And this is the project that actually made me a super fan of his work. I forgot what it's called. I think it was called iWriter. So there was this graffiti artist who was paralyzed and could no longer do their traditional medium of art. And Zach, and I don't know if it was a team or not, created this whole program where it was tracking eye movements and then translating that into drawing sketches on a computer, which then a robot could then replicate and make out of spray paint. And I think that is like one of the most beautiful, amazing creative tech projects that just like solve a very important project and problem and completely blends code, robotics, design thinking, empathy, everything. And I really look up to his work. He also posts really beautiful sketches. He calls them sketches, digital art online. Very talented person.
That's incredible. I'll have to look into that a little more. I'd never heard of that project. The question I like to end on, because I always think it's kind of an interesting window into someone. Is there any aspirational figure, like someone big in like the tech or art world or science or education, that you'd love to like grab for a couple hours and just pick their brain over lunch about like how they do what they do?
Yeah, being a big fan of Zach Lieberman's work, I would love to kind of have a conversation with him and see how he approaches creating, because open source software and tooling is kind of just like a paintbrush. It's just a tool for creativity. And I would just love to have a conversation with him on how he approaches making tools for artists and developers, because I would love to learn how to do that myself through my work.
That's fantastic. Well, thank you so much for your time, Arielle. I really enjoyed our conversation here. Um, we'll include links to find some of your awesome tutorials and your work at Viam.
Thank you.
But thank you everyone for listening. I hope you liked the episode, and definitely keep following along and subscribe for more. But
Thank
happy
you so
hacking.
much. Yeah, thank you so much for having me, John. This was awesome.
The State of Developer Education is brought to you by Major League Hacking. To find out more about Major League Hacking and how we're educating the next generation of developers and helping the world's leading companies reach them, visit sponsor.mlh.io. And make sure to search for developer education in Apple Podcasts, Spotify, Google Podcasts, or anywhere else you listen, and click like and subscribe so that you don't miss any future episodes. And if you like it, please don't forget to leave a review, and we'll give you a shout out on a future podcast. On behalf of the team here at Major League Hacking, thanks for listening and helping us empower the next generation of technologists. Happy hacking!